O is a point in the interior of a square ABC such that OAB is an equilateral triangle. So we have equilateral, square and all of that. Show that OCD is an isosceles triangle. As of now, things are not very clear for me. The very first thing I have to do is, yes, draw a square. And then the investigation starts. I think that looks like a square. Okay, then we have here ABCD. So we have a point O such that OAB is an equilateral triangle. Okay, so somewhere over here, I think. So what they're telling is this. Oh yeah, by the way, first thing is first. We have this to be an isosceles triangle, sorry, not isosceles triangle, equilateral triangle, and this to be in square. So let's mark the obvious. So all the sides of a square are equal. So we have x, x, x and x. And this is 90, 90, 90 and 90. This is an isosceles triangle. So we have all the sides to be equal. So since one of the side is x, this too will be x. Then we have triangle this, OCD. Clearly these two sides are equal. Obviously we have to prove something like that. Only then we can tell this is an isosceles triangle. Now, how can we prove that these two sides are equal? If not, these two angles are equal. Anything is okay because, well, you have the property of an isosceles triangle to be that. Right? Either two sides, if not two angles are equal, and vice versa. Any one can be proved from the other. So any one of it is good enough to prove that they are, or it is an isosceles triangle. How will we do it? I think we can go with the sides, guys. Forget about the angles. Right? I'm thinking of proving this actually. I'm thinking of proving this length. Oh, sorry, not that. This length is equal to this length. How? With the help of triangle ADO and OBC. Think how? Where am I taking this conversation towards? Yes, I'm thinking of what? Congruency. It's clear. These two are congruent, right? We have two sides that is equal. The included angle, yes, as of now it is not equal. We have to prove that. How? Well, this is an isosceles triangle. I missed one thing. I told you always write things which are obvious. In an isosceles triangle, all the angles are 60. And in a square, all the angles are 90. So this is 60. This entire thing is 90. So this has to be, yes, 30. And this has to be also 30. Done. Two sides and the included angle are equal. So these two triangles are congruent. And so we have DC equal to OC. And so this is an isosceles triangle. That's it. Okay. So now we just have to write this sequence of thinking to prove. What is that we want to prove? Triangle OCD is an isosceles triangle. Now we have the proof. How will we start off with? We will start off with this actually. As not O, ABCD is a square. We have AB is equal to BC is equal to DC is equal to AD, which in turn is equal to X. We are calling that actually let A be equal to X, and we have all of them to be equal to X. Therefore, BC is equal to DC is equal to AD is equal to X as well. Okay. So that is established, and also angle ABC, which is equal to angle BCD, which is equal to angle CDA, which is equal to angle DAB. All of them are equal to 90 degree. Okay. Yeah, that is with your not isosceles triangle, square. Now we have triangle ABO. In triangle ABO, as it's an equilateral triangle, what is that we're looking at? We're looking at OA is equal to OB is equal to AB, right? Which in turn is equal to X. This is from 1 because of 1. Okay. Actually, I need not write that, but anyways, I wrote it off because AB is X now, so not an issue. And we have individual angles like OAB, ABO, and AOB. All of them are equal to 60 degree. So we have our initial sequence of thinking written, and now on to the congruency. In triangle, or consider triangles. Consider triangle AOD and triangle BOC. So what is that we're looking at? We have AD, which is equal to AO, right? Or let me go with this. AD is equal to BC, which is equal to X. And we have AO, which is equal to OB, which is equal to X2. And we have DAO is equal to BOBC, right? Because they are 30, we have to prove that actually. So let me do that individually. So we have the next step is angle DAO, which is equal to angle DAB minus angle OAB. This in turn is 90 minus 60, which is 30 degree. We have written everything, don't worry. Right? We have written that this is 60 and this is 90. So this is, right, on substituting 30. So you don't have to explain more. That's good enough. And we have OBC, right? OBC is equal to angle ABC minus OBA. So this is 90 degree minus 60 degree is equal to 30 degree. And therefore, conclusion is what? Angle DAO is equal to angle OBC is equal to 30 degree. With all of the above, what is that we can conclude? Thus, triangle AOD is congruent to triangle BOC by what? Side angle side similarity criteria. Okay. So with this, I can tell by CPCT, by corresponding parts of congruent triangles, I can tell that we have DO is equal to OC. OD is equal to OC. Okay. And now on to the triangle. Thus, triangle ODC is an isosceles triangle as two of its sides are equal. And that would be your answer, hence proved. Okay guys, see, only the last bit was your hard part. That only one bit, that talking about these two triangles to be congruent, was the one which we had to figure out. Proving that they are congruent is not difficult, but how to link the given set of information to proving what we want was the one which is the difficult part. So that's where you have to think. If not, everything else is obvious. And I showed you guys that how I think. The sequence of thinking is what is important. That's what you have to learn. Don't learn how is that I'm doing this question, right? How is that I'm writing this? Like, let me copy this. That should not be the agenda. You should be looking at the sequence of thinking I have. I just draw the diagram, write the obvious, call x and y and so on and so forth, and look into how we can prove that ODC is an isosceles triangle. But in the background, what should we be thinking? Okay, if I have to call this as an isosceles triangle, what conditions should it satisfy? Well, we have two angles, or if not two sets of two sides to be equal. Any one of this will help us out. So then I went on to talk about, okay, these two sides has to be equal. If not, these two angles has to be equal. So which is better and which I can prove faster? Either of this can be proved not easily, but yeah, either of this two angles, if not two sides, can be proved in different ways. But I felt as of now this is the simplest way. Okay, guys. So point is, you don't have to by heart anything. Please don't by heart anything. Right? It will be obvious as and when you write things, and that's how math should be learned. Okay, now it's time for you guys to pause and have a look at the answer.